looking at now is very similar to what we just did in the last lesson, right? So what I thought we could start off by doing was giving you an opportunity to see whether you would be able to answer this question, okay? And then we can move on to something that's a little bit more difficult. Is that okay? Does anybody feel as though they would need help to be able to do this, or is it okay?
It's okay, ma'am.
Is it okay? Okay. Anyway, so Tatso, give it a try. Just give it a try, okay? You don't have to, even if you get it wrong, it doesn't matter. Do you want me to give you some clues? Okay, so let me give you some clues then. All right, so in this diagram, they have told us that PA is parallel to BC. So straight away, when we see that they tell us that lines are parallel, we not need to start thinking about all the special kinds of angles that we get when lines are parallel. So if you go back to grade 8, right, you can think about what lines are equal because of parallel lines. Alternate angles. Do you remember alternate angles? Exactly. Corresponding angles. And then the other kind of angles that we got, although they're not equal to one another, was co-interior angles. But co-interior angles are not so useful to us because they're not actually equal. They're add up to 180. But certainly alternate and corresponding could be very useful to us in this situation. So I've drawn arrows on the lines that they told me are parallel. And now I can see I've got a diagonal here. So straight away, Matrix, look at this. This angle over here and that angle over there. Right, they are alternate angles. All right, so that means that they will be equal to one another. The other thing that they've also told me in the information that's been given on the left-hand side over here is that angle B1 equals angle C. That's been given to you. Okay, so here B1 and C are equal to each other. All right, so that means that we've got everything that we need in order to be able to prove that these triangles are similar to each other. Okay, so I think just for the people that weren't in the previous class, let's just go through this one more time. And I don't think that it's going to hurt any of us to be able to hear it. Okay. When they tell us that triangle, and I'm going to write it over here and I'm going to have to rub it out afterwards, but it's fine. When they tell us that triangle PAB is similar to triangle ABC, they have given us wonderful, wonderful information, all right? So what they are telling us, because of the order of the letters, that's a very, very important clue. The order of the letters is really, really important. What it means is that when I write the letter P on its own, I'm talking about angle P in the one triangle. Okay, so that's this angle up here, right? Then if angle A comes next, then what it means is that these two angles are equal to one another. Okay, so triangle PAB is this one over here, and triangle ABC is this one over here. Okay, so one's not inside the other one, the common side in this case. So P over there and A over here are equal to each other. Right. The next letter that I see is letter A. So over here, this angle A corresponds with this angle B. These two are equal to one another. And then it means exactly the same thing with the last two letters. Angle B and angle C are equal. Angle B and angle C are equal. All right, so it tells you which angles are equal to one another. And that's really helpful because you can use that to help you with your solution. So angle A and PAB is equal to angle B and ABC, and angle B in PAB is equal to angle C in ABC. So those are the three angles that are equal. But it's not just that, matrix. It's not just about the angles that are equal. We can also say something about the sides. So this is what I was saying in the previous lesson. Okay, if I take those first two letters together, so PA, side PA corresponds with the first two letters over here with side AB. Now, side PA, which is the side up here, and side AB correspond with one another because they are both opposite angle, B and C that are equal to one another. Okay, that's why they are corresponding sides. Okay, so angle PA is opposite angle B1, angle AB is opposite angle C, and B1 and C are equal. That's why PA corresponds with AB.
Sorry, ma'am, could you please just repeat that one more time?
With pleasure.
Sorry.
So when we talk about sides that are corresponding, Bonnie, okay, in this context over here, when we talk about corresponding, let me write it down for you, corresponding sides, okay, means sides opposite angles that are equal. Okay, so the reason that PA corresponds with AB is because they're opposite angles of the same size. So you know what we mean when I say the word opposite? Okay, so here's angle B1, it is opposite PA. Here's angle C, it is opposite AB. Okay, so sides correspond with one another when they are opposite angles that are the same size. Okay, does that make more sense?
Okay, that makes sense so much.
You get it now, okay. Yes. All right, and then over here, if you have a look in triangle PAB, angle A1, this angle over here, it's opposite side PB, isn't it? It's opposite side PB. Yes. Okay, so side PB. All right. Now, what angle is equal to A1 in the other triangle?
B2.
B2. So it is opposite AC. All right. And that's why PB and AC correspond. So look here, Bonnie, there's the P and the B first and last, and there's the A and the C first and last. Okay, you see, this is why the order is so important.
Okay.
Hi, all right, is it starting to make sense now?
Yeah.
Okay, yes, and that's why you've got to, that's why it's so important, the order. That's why the order is so important. Okay, and then the last thing that I wanted to say, yeah, it's starting to become clearer now. That's awesome. And then side A, it's a pleasure. It's an absolute pleasure. And side AB and side BC are also corresponding. AB corresponds with BC. So AB is this side over here. It's opposite angle P. And side BC is over here, and it's opposite angle A. All right, and angle A2 and angle P are equal to one another. All right, so that's why sides correspond. Okay, when they are opposite angles of the same size. So now all of this is very helpful because they're literally telling you which angles are equal. All you need to do is describe whys, is find the reasons why. That's what's so awesome when they tell you in which triangles you can work. Because straight away you can see, well, angle P in the first triangle equals angle A in the second. And angle A in the first equals angle B in the second. And angle B in the first equals angle C in the second. We just need to find the reasons why. Okay, so now when we set out a similarity proof, we have to write it in a certain way, matrix. So we have to set it out as follows. In triangle PAB, yes, Cassandra, what's your question?
So, ma'am, when I'm proving similarity in a quadrilateral, ma'am, do I use the angles or the sides, or can I decide which ones to use?
You would have to decide which ones to use. You'd have to be told which ones were equal to one another.
Oh, okay.
Okay, all right. But I don't think that they will get you to prove similarity in quadrilaterals, Cassandra. It's normally in triangles, because something different happens with quadrilaterals that doesn't happen with triangles. You see, with quadrilaterals, angles can be equal, but the sides are not necessarily in proportion.
Okay.
It's fine touch doesn't happen. If angles are equal, sides will be in proportion. Okay. All right. So
Thank
now
you,
we're going
ma'am.
to set. It's a pleasure. All right. So now let's set out our proof. Remember, we already know that angle P and angle A equal one another. But that's not something that we were given in the beginning. Remember, we're only allowed to use angle, sum, and triangle as our last reason. Okay, so we've got these alternate angles over here, and then we were given that this angle over here and that one over there were equal. All right, so reason number one can either be B1 equals C, or A1 equals B2. Okay, either one of those two has to go first. So let's say we decide to go with angle A1 equals angle B2. And that is because PA is parallel to BC. Now, that is considered something quite, well, not easy, but, but this is something from grade 8. All right, so that's why we would just get one statement reason mark over here. The second thing that we have to state is about angle B1 being angle equal to angle C, and this was given. Now, and only now, it's only once you've proved the first two using other reasons, only now can you say, well, the remaining angles must be equal. Okay, so in other words, angle P has to be equal to angle A2 because of angle, sum, and triangle. So that means angle, sum, and triangle means that the angles of a triangle add up to 180 degrees. Okay. You cannot start off saying this first. Okay, if you make this statement first, you're not going to get the marks. Okay, it has to be the last statement. Okuhle, go for it.
Ma'am, for angle P and A2, can you just say remaining angles are equal for your reason?
Absolutely. No, you can say that, Okuhle. You can say remaining angles of triangle are equal. That's fine. But it has to be the third thing. Okay, you can't as reason number one, say angle P equals angle A2, remaining angles of triangle. Okay, so it has to be after you've proved the first two. That's the only time that you can use that reason. Okay, all right, good stuff. Pleasure. Okay, so now that we've proved that these triangles are indeed similar to one another, we can now conclude that they are similar and state the corresponding sides that are in proportion. Okay, so triangle PAB is indeed similar to triangle ABC, and we've proved that from angle, angle, angle. Okay, so we're all happy. We've managed to do the first question A-okay. Any questions, Matrix?
No, ma'am. Oh, sorry.
It's okay. Go for it.
The reason why we saying that angle P is equal to angle A2, and then we saying that angle in triangle, is it because that's the last angle we're proving?
Correct, Cassandra. So in other words, what we've done is this, is we've said in triangle PAC, the following is true, all right? Angle A1 plus angle B1 plus angle P adds up to 180 degrees. Okay. Then in triangle ABC, we are saying that angle B2 plus C plus A2 adds up to 180.
Yes, ma'am.
Okay. Now, if you have a look at this statement, all right, what's so interesting here is this, all right? If angle A1 and angle B2 are equal to one another, and if angle B1 and angle C are equal to one another, right? Then that means that the remaining two angles have to be equal to each other, okay? This one over here has to be equal to this one over here because they all add up to the same thing. That's essentially what you're saying. All right, so we need good geometrical reasons for A1 equal to B2 and B1 equal to C. And then once we've proved that those two are similar, we can conclude that the last pair are equal because of angles of a triangle or remaining angles of a triangle. Pleasure. Okay. All right. So now that we've got we proved that the triangles are in proportion. Listen to me. Now that we've proved that the triangles are similar, we can write down the sides that are in proportion. So remember, in geometry, we write a side using two letters. Okay, so if I write the letter P, that's not a side. Okay, so P on its own is not a side. That has to be an angle. Okay, but PA, that's a side. Okay, so in other words, it starts at P and it ends at A. So I'm talking about this line segment over there. That's PA. All right. Now, PA are the first two letters in this triangle. If you've got the order of the letters correct, then it means that PA will correspond with the first two letters in this one over here. So PA over AB. Then the second two letters. So now let's do that letter, those two letters and those two letters. All right, so here AB corresponds with BC. And then matrix, it's first and last. So PB, PB, and that side corresponds with AC. Okay, now once you've stated that, you also need to provide a reason. By the way, how does everybody feel at this point? Is it making sense? Matrix, how do you feel?
Good.
We're good, ma'am. Thank you.
You're sure you're okay? All right, so now we've written the sides. Let's just see what's going on in the chat. What's happening with my pen here? Oh, sorry, it's because I'm sitting here in the dark. So it's a little bit difficult to see where everything is now. Okay, so Katlejo's smiling, Tadalwetu's happy, Tatso's got a thumbs up, Dalen, yes, I get it, Balungia's thumbs up, I feel good. Nice, all right, okay, cool. I'm glad that this is making sense to you. All right, so now that we've written down the three pairs of corresponding sides. We say that the reason why this is true is because they are the corresponding sides in similar triangles. So the corresponding sides are in proportion matrix. Okay, and now any two combinations. So remember, a proportion, okay, is something over something equals something over something. All right, so there are a number of different proportions we could make here. Either we could say that PA over AB equals AB over BC. Or we could say that AB over BC equals PB over AC. Or first and last, we could say that PA over AB are three different combinations that I can make. All right, if those three things are equal, I can make three different equations. Okay. Okay, now let's just highlight, or I can do this one, or that one over there. Okay. It depends on what it is they are asking you for. So if we go back up here, look, we've got PA and AB and BP and AC. So PA and AB, PA, look there, PA and AB.
Ma'am.
Right. And it goes with PB and AC. PB and AC. PB. Did I do something wrong here? Hang on, PA over AB. All right. PA over AB is AB over BC is, oh, I see what I've done wrong here. Okay, when I did first, no, that was right. PB, AC, no, I haven't done it wrong. Okay, so what we...
Oh my goodness, we've lost her. All right, guys, just give me a second. Let me see if I can get her back. Okay, but in the meantime, I'm going to share that same screen that she was just showing us. It's not going to come with all the all the writing that she had on her screen, but you'll at least be able to see question B and C. And if we can try that in the meantime while I try to get her back on the line. Does that sound okay? Can everybody give me a thumbs up?
Yes,
I'm
ma'am, that's okay.
here.
Thank you.
Oh, are you here? Oh, wonderful. Sorry.
I'm here. Sorry, yes, no, you did lose me. And I was busy explaining and you were dead quiet and I was like, Okay, so hang on a second. Let me share my screen again. Sorry, unfortunately, this is load shedding. It's just such a problem, isn't it? It really is.
Yeah.
Okay, can you see my screen again?
Yes.
Yes,
Okay.
yes, ma'am. Thank you.
All right. Okay. All right. So we were talking about this second question over here.
Oh, sorry, ma'am.
Coco, I know you were going to say something to me. Did I make a mistake somewhere? I didn't think I had. But
Oh,
maybe
no,
I
you
did.
didn't. It's just you do sound a little groggy on my side. So I just wanted to ask if the kids hear that grogginess as well.
Same on my side.
Same on my side,
same.
ma'am.
Same.
Yeah.
So I think it might be the network. So Lee, I don't know if your camera is still on. So maybe if you want
Maybe I
to
should
switch
turn my camera off.
Yes.
Okay. All right.
And that might help the bandwidth a little.
Okay, all right. There we go. I've switched it off. Does that sound better?
Yes, ma'am.
Yes.
Am I sounding any better than I was?
Yes, ma'am.
Just my camera. Okay, all right. Okay. My apologies, guys. Hopefully load shedding won't be part of our future for too much longer. Okay, so we were talking about PA and AB, right? So I drew a circle around the wrong AB. Okay, so PA and AB. So PA over AB was that one over there, all right? And EB and AC. Okay, so it's actually this combination over here. So PA over AB equals PB over AC. It's actually that combination, the purple combination at the end. AB. Okay, so what we're doing is we're comparing numerator to denominator with numerator PB to denominator AC. All right, so again, if you think about it in terms of numbers matrix, 1 over 2 is 5 over 10, right? Remember, we are comparing numerator with denominator. So we are saying that 1 is to 2 is the same as 5 is to 10. That's what this means. Okay, essentially. Okay, so when I compare numerator with denominator, it's the same.
My word, guys. Sure. Okay, hopefully she'll be back on in just a sec.
I'm back again.
Oh, good.
Sorry, my connection is really bad this evening. I don't know what to do.
Okay, I think at this point, Lee, if we can just have a look at question B and C. And I don't know why, but I don't have the notes that you're currently teaching from. I only have the ones on sequences and series. So if you wouldn't mind, oh, no, I do have them. Okay, so I'm going to open up this exact one that you're working on now. And if you happen to have another issue, I will then quickly share my screen while you get, while you get everything together, and then the kids can try the rest of the questions while you're off.
Okay, all right. I have explained question B, but it might have been when I wasn't part of the Zoom meeting. Do I need to explain question B again? Did you guys miss that?
We were just at the end where you're explaining how we compare numerator with numerator and denominator.
Numerator with denominator and numerator with denominator. Okay, so this is the answer. This over here is the answer. This bit here is the answer to part B. All right, so what we would have done.
I can't see your screen.
Oh, heck.
Oh, goodness, you're not sharing.
Am I not sharing?
They're seeing my lovely face, actually.
Yes.
Well, that's a nice thing for us to look at. Certainly better than maths, that's for sure. I don't know what to do. I mean, I think my connection is obviously very unstable.
Oh, no. There, I need to make you a host. There you are. You're now
Please
host,
make me. Okay. All right. So now maybe I can try sharing again. Okay. Let me just see what I can do now.
I need to go.
How's that?
Oh, awesome. All right. We see you now.
All right. Awesome. Sorry, guys. Thank you for being so patient while we're busy sorting out all this. Okay. So see I've highlighted PA
Yeah,
over
ma'am.
AB in purple over here.
What, ma'am? Ma'am?
And now I'm going to go
Ma'am.
and highlight
Ma'am?
the
Ma'am.
other two.
Ma'am,
So
excuse me,
it's
ma'am.
PB.
Just hold on, guys. Let's
It's
give her a
this
second.
combination. And then what you can do, PA over AB is equal to PB over AC. Yes.
The screen is black, ma'am, and we can't hear you.
We can't hear you at all, ma'am.
Oh my goodness.
My side of the screen is
Can
showing
you
you. I
hear
can't
me?
hear her. Not properly, you're shaking.
All right.
Ma'am?
Okay. Guys, I think the best thing to do at this stage, I'm going to put up the next question quickly. And then from there, I think I'll try and explain from where ma'am left off. How does that sound?
It's perfect, ma'am.
All right, so I'm going to share my screen and we're going to be looking at the first question and we're going to try our best to answer it while we wait for her to sort that out. All right, here we go. All right, so this is what we're looking for. And it says in the diagram below, and we're looking at the triangle up top. Okay, I'm unfortunately unable to edit this the way I would like because it is actually Lee who can edit. There we go. Okay, she's given me editing rights. We're going to be looking at the first one. In the diagram, EF is similar to CGD. Now, what we're looking at here will not be an angle because they've only given us two sides. They've given us sides EF and sides CGD. So what are we going to be using to solve this? It won't be angles anymore. What will we be using to solve for this? You can tell us.
Ma'am, when you say it won't be angles, what do you mean by that, ma'am?
What other way can we prove that triangles are similar other than solving for angle, angle, angle?
We can use the sides or
Yes, we can use the sides and they have to be in proportion.
proportion, yes.
So what we're going to be looking for here is which sides are in proportion. And this is quite helpful in that they've given us parallel lines. Can you guys see that EC and FG are parallel? And that EF and CG also parallel. And we've then got a parallelogram. And there are a few things that we know about a parallelogram that we're going to be using to prove this. Nkosinathi, proportionality theorem would be if we're trying to prove that sides in a particular triangle, actually, yes, you can. CB and GF will also be in proportion. So, yes, so we can also use that.
Can you guys hear me now?
Yes,
Sorry
we can.
to interrupt you.
No problem.
Can
We
you?
can hear you, Lee. I've just moved on to the next question. We're moving on to question 3. I can't, unfortunately, edit anything on my side. So I'm going to need you maybe to take over.
That's fine. Hopefully it's going to be stable for the rest of our time together. If you make me host, then I can. Thanks, Coco. Thank you for doing this.
No problem. Oh, we're gonna hate load shedding, guys. It's really just ruining.
It's ridiculous.
Yes.
Now, it keeps telling me my connection is unstable.
Yeah.
Anyway.
So if we can just, I'm going to stop sharing my screen and then you and I can swap over. How's that sound?
That sounds good. Let me try and share my screen. Here we go.
Ooh, honestly, I think that's where the problem starts, when she's using too much of her data.
Is that okay? Can you guys see my screen?
Oh, gosh.
Okay. Can you not hear me anymore?
We hear you. We can hear you, ma'am. Oh, goodness.
Oh, can you hear me?
Yes, I can. It's just not all that great. It's not so wonderful.
Can you?
Yeah, I can hear you.
Can you hear me, Coco?
Yes, ma'am.
Okay, all right. So if I disappear again, then just tell me, okay?
Will do. I will tell you on WhatsApp. Okay. And she's gone again. Word. Okay, I think we're just going to have to keep switching between her screen and mine until we can figure this out. Okay, guys, can I ask you to do me a favor, please? If you guys can maybe take a screenshot of what's on the screen at the moment. Okay. And then we can try that so that next week, when we get started with this again, we won't have the same issues that we're having today. Tatsu, we are not going to go sleep. We're going to go try these questions. Okay, maybe we can try question 3. And then next week, we can ask Lee to pick up where we left off. Okay. I'm sorry about that. I'm very sorry, guys. Okay, so if you can take a screenshot, or maybe you can draw this on a quick piece of paper, and we're going to pick it up again next week. Unfortunately, there isn't much we can do on this side. I don't quite have my own tablet and my stylus in front of me, and to set that up would be just a huge mission, guys. We're so sorry for this. Okay. Wonderful, Bonnie, thank you. And we can go try this particular question, and we're going to try and look at what they're trying to teach us from this one, but we'll have Lee here to help us with that one in that moment. Okay.
Yes, ma'am. Thank you.
I'm very sorry about this, guys. And yeah, unfortunately, there isn't much we can do about it. Yeah, and we are trying to get all our teachers in the company UPSs. That's like another plug for their Wi-Fi, so that we don't have these kind of problems. But for now, I'm very sorry. We'll continue this.
Come in.
Week. I'm going to stay on the line until 7 in case any of you guys have any questions while you're working, so you can try and work through these. Unfortunately, Lee has taught matric, whereas I teach grade 10 and 11, so I'm not as skilled in this as she would be, but we will continue. Okay, so if you want to stay on the line and work through these, there are parts where I can help you and see what I can help you with as well. Okay.
No problem.
Okay, thank you, ma'am. No problem.
Okay, I'm back.
Hi, Lee.
Again.
Oh
Sure.
my goodness, this is so
Yeah.
ridiculous. I'm so sorry, Matrix. We're going to have to do something about load shedding in the future. Okay, so Coco, you were talking about line, pardon?
Could I try something quickly?
Sure.
Would you like to draw on your screen right now?
Okay, let me try and draw on my screen.
On question 3, around the area.
Yeah, I'm trying to draw on it. I can't draw on it.
Is it maybe because I'm in?
It's because you're in here, yes. I mean, I can tell you what to do, And you can do it if you want. We could do it like that.
Yeah. Okay, yes, we could. Just give me a second. I need to gather myself. Sure, this is quite the drama we've got going here today.
Absolutely. Like no other.
My word.
Okay, so in the chat, Katlego said, is side BF equal to BD? No, no. In this particular question, they've told us that sides are parallel, all right? So when they've given us lines that are parallel, we also need to look for angles like corresponding angles or alternate angles or whatever the case is. So triangle BEF, if you just highlight BEF, please, Coco. Triangle BEF. Okay.
It's taking just as long on my side. This is very worrying.
Oh, wow. Okay.
All right. So I'm highlighting triangle
BEF. Yes.
I'm going to try and keep up with you as we go.
Mom, could we possibly say that F2 is equal to G2 because of alternating angles?
Yes, absolutely. But the problem is that F2 is not in either of those two triangles.
Oh.
So what I actually wanted you to see here is that angle F1 equals angle D. Can you see that?
Sorry, ma'am, again.
Okay, so angle F1 will be equal to angle D because of the parallel lines. Sorry, it's so difficult for me to show you this now because obviously I can't. There we go. So
you can continue speaking.
She's highlighted BEF.
Yeah.
All right, and then you can highlight FGD.
FGD.
Okay. All right. So what we can see in this situation over here is that angle F1 and angle D will be equal to one another. Okay, because they are corresponding angles. I don't know if you can see the F lying on its side. Line BD is the transversal, and because EF is parallel to CD, that makes F1 equal to D. Okay, so we would be able to say one of the reasons why, well, the reason why F1 equals D is because of corresponding F is parallel to C. So the F is upside down, absolutely. The F is upside down. So the BD is the transversal, and then it's, okay, so that's why angle F1 and angle D are equal to one another. Perfect, there we go. All right. Now something else that's important for us here is that angle E1 would be equal to angle C. Angle E1 would be equal to angle C also because they're corresponding angles. So angle E1 would be equal to angle C because of corresponding angles, and angle C equals angle G2 also because they are corresponding. So if both E1 and G2 equal angle C, then it means that E1 and G2 must be equal to one another. Okay, so E1 equals C corresponding angles, and C equals G2 corresponding angles.
Okay, and you have to remember to also put the parallel lines as well.
You do have to remember to put the parallel lines.
Right. Right, ma'am, I'm with you. Let's go.
Ma'am,
Excellent.
sorry.
Yes,
So,
Bonnie.
ma'am, is it if E
Oh.
parallel to CD?
Okay, so the reason that E1 is equal to C is because EF is parallel to CGD, so that's correct. And then C equals G2, that's because, oh, sorry, Coco, in your third
what?
line, sorry,
Yes,
your
I just
parallel
noted.
lines,
No, I
okay,
did
so
not just
because PC is
PC
parallel
is
to,
parallel
BC
to-
parallel to FG. Yeah, if you can just change that. Thank you.
Yes, that should
Sorry,
be-
ma'am. I just wanted to ask.
yes.
Yes, go for it, ask.
Oh, okay, sorry. So I see the corresponding angles between E1 and C and G2, but I'm struggling to see the first one, ma'am.
I know, and that's why. Okay, so Coco, can you do this for me?
Hmm.
Okay, delete the blue lines and the blue angles and the yellow lines on the diagram.
Hmm.
Okay, so delete all of that and then just get one color, a
Yes.
different color like green or something.
Okay.
Okay. And I want you to highlight line BD. And once you've highlighted line BD, I also want you to highlight DG, just to help Bonnie see that.
Yeah, I'm really sorry, Lee. I have actually deleted them on my side. They just haven't caught up on my computer.
That's fine. That's fine. That's okay.
Oh, there we go. All right. So I'm highlighting BD.
BD.
Let me see if I can't. BD here. There we go. Hopefully it will come up.
And then highlight EF and highlight GD. And then the students will be able to see why angle F1 and angle D are corresponding. It's difficult to see.
Yeah. My apologies. It just takes a lot longer because I'm using a tablet and not a Wacom. Have I done that correctly? There's one line missing, but it should show up in a bit.
Oh, I see it. Okay.
There you go. Okay, and then just do GD as well. You've done GD.
Yes, it just hasn't shown up
Okay,
yet.
so just give it 1 second, Bonnie, and then line GD is going to pop up, and then you're going to be able to see the F lying on its side, head down. There we go.
Okay. Thank you so much, ma'am. Okay, I see it now.
Okay, so can you see why F1 and D are equal to each other now?
Definitely, ma'am. Thank you so much.
Oh, that's awesome, Bonnie. I'm so glad. So despite everything, we've managed to get through all of this. All right, so if F1 equals D, angle G2, yes, will be angle, angle, angle. That's right, Zia. Okay, it will be angle, angle, angle. Okay, so those two are equal. E1 and G2 are equal. So now we can conclude that B equals F3. B equals F3.
Sure.
And the reason that B equals F3 is because of
Remaining
angles in a
angles.
triangle, because the angles of a triangle sum up to that's it, remaining angles of a triangle. Quite right. Okay, and then Coco will be able to write, therefore, triangle BEF is similar to triangle FGD. All right, and then we need to make a statement about the sides. All right, so just wait for that for Coco to catch up with that. In the meantime, you can write that, guys. If you've got what's on the screen here, you can say, therefore, angle B equals angle F3, remaining angles of a triangle, or angle sum and triangle. And then you can say, therefore, triangle BEF is similar to triangle FGD.
Sure, I'm so sorry. I don't know why it's taking
It's
so
okay.
long.
No, it's just, tonight's just been a bit of a mess.
Mm.
Okay, so triangle BEF, similar to triangle FGD, angle, angle, angle.
Okay. Well, it should have come up by now, and I'm very sorry that it hasn't yet.
Yeah, it's not your fault. It's not your fault. Unfortunately, we have load shedding, and that's what's created this mess for us today. Okay, so now, Matrix, have you managed to write that down, Matrix?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
All right. Okay, guys. Okay, so now, okay, we're going to write the corresponding sides in proportion. Okay, so this is what I need you to write next. Okay, BE over FG. BE over FG equals EF over GD. So EF over GD equals BF over FD. BF over FD. All right, so what you should have written is BE over FG equals EF over GD equals, sorry, the notebook's gone.
I'm sorry, I'm just trying to refresh so that it can get back to where we were just now. And hopefully all that was written down should come up, and it has not. Oh my God.
Okay, so it hasn't. Okay, but anyway, it doesn't matter. So BE over FG equals EF over GD equals BF over FD. All right, Matrix, and then next to that, you must write corresponding sides in proportion. So you can just write CORR, sides in prop. You don't have to write any more than that. Okay, corresponding sides in proportion. Okay, so this is going to be, I think, the last thing that we're going to be able to do, because time is basically up. This has been a bit of a disaster lesson for all of us, but anyway, I'm just writing down what I've told you. So we've got BE over FG equals EF over GD equals BF over FD. Okay, now they want DG. So if you've got a highlighter with you, highlight the letters GD. Okay, now highlight the letters FG. Highlight the letters EF and highlight the letters BE. You should see that you've got BE over FG equals EF over GD. All right. So now from that, from BE over FG equals EF over GD, what they have done is they have cross multiplied. Okay, so BE and GD have swapped places. FG and EF are still where they were, but BE and GD have swapped places. All right, and that is one of those switches with proportions that we are allowed to make. So in the next line down, we're going to put GD where BE was. So GD goes at the top over FG, and that's going to be equal to EF over BE is now at the bottom over GD. Does that make sense, Matrix?
Yes, ma'am.
Okay.
Ma'am,
Yes, Sinesipo?
can you please repeat what you said?
I will with pleasure. Okay, so after you've got your three proportions, so BE over FG equals EF over GD equals BF over FD, you've written corresponding sides in proportion. Then you must write BE over FG equals EF over GD. I'll say that again. BE over FG equals EF over GD.
Thank you,
Oh,
ma'am.
there we go. Okay, so Coco's got it on the screen. Lovely. Okay, and now, awesome, Coco. Thank you. And now BE and GD need to swap places. Okay, so they will swap places with one another. Okay, so interchange BE and GD, please, Coco. Yeah, boo.
There we go.
That's it.
Hopefully it did justice.
You certainly did, and your handwriting is so much nicer than mine. That's perfect. There we go.
Okay, ma'am. So
Yes, Bonnie.
why do we interchange GD and BE?
Because of the question. So Coco, just scroll up a little bit and let Bonnie and the other matrix see the question. Look what they were asking for in B, Bonnie. Can you see they were asking for DG over FG equals EF over BE? That's why we interchange. Okay,
Oh, so
because
you're allowed
that's
to
what
do
they...
that without giving reason. You're just allowed to
Absolutely, absolutely, absolutely. Because remember, go back to that whole 1 over 2 is 5 over 10. Okay, so if we interchange, the 1 and the 10, do that on the side, Coco, 1 over 2. 1 over 2 equals 5 over 10.
It should pop up in just a sec.
And then we interchange the 1 and the 10, we're still going to have the same thing, because then you would have 10 over 2 equals 5 over 1. Does that make sense, Bonnie? And the answer is still the same, exactly. So this goes back to that first lesson that we had, Bonnie. Do you remember when we were talking about proportions and all the different combinations we could make? That's what we're back at now, okay? Here we go. Okay, you see the connection between everything.
Thank you, ma'am.
It's a pleasure. Thank you for being so patient with the way things are.
No problem.
Okay. All right, there we go. Excellent, Coco. So now if we interchange 10 and 1, it still means the same thing. All right, so 10 over 2, 10 divided by 2 is still 5 over 1. Okay, matrix, awesome. Well, I think despite the load shedding and the drama we've had, at least we've managed to get through that question, and hopefully all of you are feeling a bit more confident and understand a little bit better what's going on here.
Yes, and apologies again for all the drama today. Hopefully we'll do better on Tuesday.
Yes, absolutely.
So, ma'am, I saw on the previous class there was a quiz underneath. Should we first wait for the video before we do the quiz, or?
Yes. I think what you should probably do is wait.
Okay.
Yeah, because we didn't manage to get quite far enough today for you to be able to do that second quiz. So yes, I would just hang on, because as long as you've done the one from the first lesson, then it should be fine.
Okay, ma'am.
Okay.
Awesome.
Okay, Matrix. Well, thank you very much for bearing with us.
Thank you so much.
We're unfortunately out of time now. So yeah, we're going to say goodbye to Coco. Thank you so much for being my right-hand man. So you're a wonderful, wonderful, wonderful teacher. Thank you, Coco. Okay. Good night, everybody.
Good night, ma'am.
Good night,
ma'am.
Thank you.
Good night.
Bye.
Good night, ma'am.
Bye.